Cubit Rod Composition, Part 2. Cubits, SI units, and the noted relationship to the British inch. General topics, root table mechanics, inner workings of a cubit rod. So what is a cubit rod and how does it function? The utilization of a unit and a constant, or an opposite and an angle, as shown in the Rhine Papyrus, number 53. A cubit rod needs to employ two pieces of wireframe geometry to compute, as seen, segment and an angle. I'll further explain in a right angle example. By assigning the square segment into a tier of rod root lengths and its diagonal or angle length into a tier of digits, in this instance, the segment of the cube equals a root length and its hypotenuse is assigned to the digits of a unit. This is the bygone ingredient of allowing geometry to energize the rod. Why a root length increment? Respectfully, we are taught to associate roots to the unit number, where geometry and unit line length never align. The line-like root length gets smaller and smaller as it graduates. Units in this fashion are not used for measurements in geometry. Whereas equal root length increments, square units, and opens geometric volume and space. All digit rods are squaring rods. Tablets such as Pimpleton 322, 1800 BC, would be the necessary steps to define and calibrate a new rod. Mathematical squaring tables are an easy understanding of the applied math and a good explanation. If you envision the entire column as line length, the vertical line shown next to the upper right table, and the rows as increments in that line, the sum or sums of the column are how root length measures increment or graduate geometrically in that line. These measures, like Pimpleton 322, would have been displayed and utilized in parallel on a cubit rod. Let's glance at some unearthed rods of the past. The tiers are labeled for this assessment. Herein, digits will be shown in a combined outgrowth communication with root length and a square segment to hypotenuse relationship, or more so, Pythagorean root 2. Squared mechanics, as depicted in Picture 2. This methodology is shown and applied into the modernized 36-digit rod of Babylonia, the last one of the three rods displayed. The standard unit will be portrayed inside of the inch to get a broader grasp of cubit scaling in a mathematical perspective. The following applied terminology is explaining the rod's build one tier at a time. Digit subdivisions, a mediator between root lengths and an inch unit that subdivides into two cubits. Cubits, 0.5 graduations of the set unit in radiant workflow, where one turn equals 2 cubits. Same mindset as radians. Fractions, as well as decimals and the inch, are respectively graduations of the 2-cubit set unit. Fractions by a simple means are ratioed by palms in 4 subunits. The denominator is the mechanism from which the cubit and digit ratio is sized. Decimals derived in the set unit. Inch bounds the unit to a set amount of digits. Root length. Root length integration allows right-angle theorem to calculate an exercise in synchronicity to the unit scale. In a further conception of root length integration, still in view of the last rod depicted in Picture 6, the hierarchy of a cubit rod utilizes root lengths calibrated with digits. In this example, in using Pythagoras root 2 as increments, a rod deployment unit of root 2 at 36 increments as shown would equal 25.4558, which is root 648 length. Keep in mind modern calculators round up. 36 increments equals 1 unit inch, 9/9, or incrementally by a 36, viewed as 36 increments equaling 1 yard. In Picture 7, the concept is shown outside the inch. Note, its scaling at 2 cubits equals a 1-inch unit. Pythagorean and Euclid math is commonly spoken in 2 dimensions, where this type of dimensional root length integration also calculates respective mass properties utilizing root measures and the right angle third leg in partnership. And since units only set scale, to remove the restraints and zero out a magnitude of geometric actions in ancient engineering, if you took the standard inch unit block and added 0.00219 inch to the inch block, or 2/1000ths of an inch, the millimeter would then calibrate to 25.455, which is root 648, root 2 at 36 increments in a 1-inch unit. This would unite the homogenized mechanics of the modern yard, the millimeter, the inch, the rationale of the Babylonian cubit rod, radial degrees, and right-angle theorem in ancient sacred geometry as it was practiced. It was really that simple. In the ongoing example of the modernized Babylonian digit rod, the root 2 hypotenuse now becomes a gateway to the square, or in general terms, opposite to adjacent, the hypotenuse into a diameter, into platonic solids, in an outreach of natural education's a right-angle theorem across geometries. Just by assigning the unit to a square segment and a constant to an angle, all mass property and vertexes are well-known ingredients bound in a unit with the numbers in a geometric locking pattern. The area and volumes in unison harmonically exercise together in a Pythagorean arithmetic. This mannerism is at the core of ancient mysticism, geometry figured from known geometry. In a further view of the Babylonian rod and how its tiers are rationalized, and to access arithmetic value, we will separately apply these equations to picture 6, the last rod depicted. This is how you gauge the merit of the rod and its numeric woven abilities. Periodic conversions, examples and calculations from digit 27. Root length times root 2 equals digit. That is, 19.091 times root 2 equals 27. Digit divided by 4 equals the numerator. 27 divided by 4 equals 6.75. Digit divided by 36 equals the inch. 27 divided by 36 equals 0.75. Digit times numerator times 2 equals root length squared. 27 times 6.75 times 2 equals 364.5. Fractional numerator times root 8 equals root length. 6.75 times root 8 equals 19.091. Inch times 9, the fractional denominator, equals the numerator. 0.75 times 9 times 27 equals 6.75. Digit times 9, the denominator, times cubit equals root length squared. 27 times 9 times 1.5 equals 364.5. Digit divided by 2 times digit equals root length squared. 27 divided by 2 equals 13.75 times 27 equals 364.5. Inch times root 648 equals root length. 0.75 times root 648 equals 19.091. Cubit divided by 2 equals the inch. 1.5 divided by 2 equals 0.75. Cubit times 18 equals a digit. 1.5 times 18 equals 27. Cubit times 180 equals degree. 1.5 times 180 equals 270 degrees. And always, decimal times 2 equals the cubit. In absolute respect to the ancients, the above example equations were to display the magnitude of geometry-driven numerology. Since I mentioned Euclid, I'll give you a quick example of rod deployment. The first square segment is dimensional to the Babylonian rod depicted earlier, 36 digits, root 648 length at 9/9. The set unit or multiples of become Pythagoras on steroids when stretching rope from vertex to vertex. As shown, the dimensions are displayed in exact digit measures, rationalized. Also, area and the volume of the cube become Pythagorean volume squaring actions, the prescript result shown in the upper right-hand corner.